Great to be here with. I'm going to go through some of the work that I've been doing on social foundations of flourishing and health, really talking about this idea of what we call social asymmetry in our research, which is that it's not enough maybe just to be lonely or feeling lonely. You can feel isolated as well, but what happens when there's asymmetries between your feelings of isolation as well as your loneliness? And then I also, in one of these studies that I'll review, we have some text data that we analyzed with a method called topic modeling. We embedded that topic modeling within a structural equation model. We'll talk about that research, but then I've also provided a synthetic data set based on that I thought we could analyze together with some code. So here's a roadmap for the talk today. We're going to talk about the measurement problem that really started this research, which is thinking about why loneliness is not equal to social isolation. And then I'm going to talk about some of the studies that we've done in social asymmetry, which is trying to codify or operationalize this discrepancies between felt loneliness and experiences of isolation, and then show how this construct of social asymmetry leads to pathways to health. Then talk about some of my work about in heterogeneity and loneliness, which is looking at trajectories and person-centered profiles of loneliness, as well as discuss flourishing in context and thinking about what well-being practices can lead to better well-being and flourishing. So in the United States, so that's really kind of coloring this talk, there's what's been called a social disconnection epidemic. It's a growing public health concern. The Surgeon General, who's like the doctor of the United States, he's talked about this problem. He wrote a report on it a couple of years ago. 50% of adults in the US report feelings of loneliness. There's been shown in meta-analysis work that there's a 26% risk increase in all-cause mortality due to feelings of loneliness and isolation. And it also has elevated risk for heart disease as well. And one of the things that is coming from the field of positive psychology that I work in is that maybe social connection can combat this. It's central to flourishing and living well in contests. But how it translates into health outcomes is only partially understood. And so what's spurring this research is that social experience is neither uniform in its effects nor simple in its measurement. And so simple models that may only look at loneliness or social isolation separately, they may obscure important distinctions between those two. So here's the conceptual problem. Loneliness is the subjective perception of being alone or disconnected. It's a felt discrepancy between our desired and actual social relationships. Whereas social isolation is the objective, quantifiable lack of a social contact and interactions. It could be in terms of your network size or the frequency of contact with families, friends, or neighbors. And why does this distinction between these two matter? Not all isolated people are necessarily lonely. We might think about this as a resilient group of people. And not all lonely people are necessarily isolated. And we might think about this as vulnerability. And their interactive effects on health may be qualitatively distinct. And treating them as equivalently may lead to misclassification and imprecise intervention. So the way we're operationalizing social asymmetry is the mismatch between felt and structural disconnection. And particularly what we do is we use the residual score from regressing loneliness onto isolation. So here in this context, positive residuals mean more loneliness than your isolation level would predict. And you can have two situations going on in this social asymmetric context. One is social vulnerability. This is when you have high asymmetry, which is you're feeling lonely despite adequate social contact. And this may reflect a persistent threat appraisal or unmet belonging needs. And then there's a class of people who we might call socially resilient. And these are those who have low or negative asymmetry. So they feel less lonely than their isolation level would predict. Again, we're looking at these residuals to figure out who's high or low in this asymmetric operationalization. And this might reflect adaptation to sparse social environments. Here's another way to look at this that I think makes it a little bit more concrete. We can think about these different asymmetry profiles in terms of this quadrant framework. You have individuals here in the top left, which we're seeing is isolated but not lonely. These are usually seen as people who enjoy solitude. You can have people who are lonely and isolated. This is a priority group, and they can be difficult to engage. They're both feeling lonely and they're feeling isolated. You have individuals that are neither lonely nor isolated, and this would be representative of the majority class of individuals. And you can have lonely but not isolated. And so this is individuals who they characterize as being lonely in a crowd. And we'll come back to these profiles in the research later. But the key idea here is that this mismatch between these two axes of loneliness and social isolation, it may be important. This asymmetry captures unique psychosocial risk that neither loneliness nor social isolation can measure alone. So the first study where we've used this, we looked at social asymmetry and its associations with physical health, operationalizing social asymmetry as we just defined it on the last slide with the residual scores. And here we were using a study. It was a large study. It was two large studies, the midlife in Japan study and the midlife in the United States study. So these are coming from adults age range of 23 to 84. There were close to 8,000 people in this sample, 1,000 coming from Japan and 6,000 roughly from the United States. Here again, we're using that residual as the operationalization of social asymmetry. And the outcome in this research was physical health. And we treated physical health as a latent variable with indicators of chronic conditions, the number of symptoms that they experience, limitations to activities of daily living, and the reported physical activity. And we looked at, we used structural equation modeling and looked to see if there was any moderation of the effect of social asymmetry on physical health by culture here, whether it be the Japan or the United States. And what we found as expected is that greater social asymmetry led to poor physical health across both nations. But this link was significantly weaker in Japan than in the US. So here we saw that cultural context reflected in norms, maybe around interdependence, harmony, and collective identity, they may moderate the health consequences of discrepant social experience. In this case, it may be that Japan's collectivist context may buffer the health impact of feeling more lonely than isolated. In this next set of studies, we wanted to know, how does social asymmetry necessarily get under the skin, looking at mechanisms of the effects of social asymmetry on health. In this study, we looked at whether social asymmetry was indicative of cognitive decline and whether or not chronic disease or allostatic load mediated that relationship. So in this study, we had 840 adults, the mean age of 54, ages ranging from 34 to 81, from what's called the MIDAS biomarker project. So again, that same study, midlife in the United States, but in this biomarker project, they collected data on blood samples. They also did some neuroimaging. So we had measures like their C-reactive protein, their interleukin measures, fibrinogen. We knew how much stress they were actually experiencing from their blood. And what we did here is we again operationalized social asymmetry as the residual of regressing loneliness and isolation. And we tested mediators of chronic disease burden as well as allostatic load using that biomarker data. And the outcomes were episodic memory and executive function. And again, we used structural equation modeling here with a parallel mediation model. And what we found was that social asymmetry primarily impacted cognitive decline through chronic disease burden. Chronic disease burden mediated that relationship between both episodic memory and executive function. But we didn't find that allostatic load had any mediating effects for the effect of social asymmetry on cognitive decline. And the implication of this study was that disease burden, not necessarily neuroendocrine dysregulation, is the primary pathway through which social asymmetry may be predicting later health. In this study, we were looking at heterogeneity and loneliness and social isolation. So in those prior studies, we were thinking about loneliness as measure, or social asymmetry is operationalized using the residual from that regression of loneliness on isolation. Here we wanted to know more about heterogeneity in these, whether we could use mixture models to unpack different profiles of loneliness and social isolation. Why does this heterogeneity matter? Well, again, we just saw that this discrepancy should matter. We see that it does have implications for health. And what also is happening here is we're assuming that there's a single underlying dimension, which is basically more lonely, more isolated, less lonely. But this may obscure individual variability in the onset, trajectory, or severity of people's individual experiences, which wouldn't allow us to maybe see distinct differences in either risk or protective factors. And so much of what we just did was in what's called a variable-centered framework, which was simply examining average associations between loneliness, isolation, and the outcomes, or that social asymmetry in the outcomes. But this may miss subgroups with distinct profiles. And so what we use in these methods are called person-centered approaches, and they include growth mixture modeling, which identifies latent trajectory classes across times, and it reveals maybe who's improving, staying stable, worsening, and why. And we also use latent profile analysis, which is a cross-sectional version of growth mixture modeling or just simple mixture modeling. And this classifies individuals into distinct multidimensional profiles of loneliness and social isolation simultaneously. So in this study, we only looked at trajectories and loneliness, and this was among US military veterans. So it was from 2,400 US veterans. There's mean age of 63. It was predominantly white sample. It was a 3-year longitudinal data from the National Health and Resilience Veterans Study. And we used growth mixture modeling. And we wanted to know what psychosocial risk or protective factors may lead to different trajectory classes of loneliness. And we found 3 trajectory classes of loneliness. We found a low decreasing class. This was a group of individuals that were characterized by low initial loneliness with a small decrease in loneliness over time. And we found that being married or partnered, having a higher purpose in life, and extroversion were predictive of being in this class. So if you were married, you were less likely to have high loneliness, and that loneliness remained stable over time. And that was also true if you had higher purpose in life, as well as if you had you're a more extroverted person. We also found, and that was the majority class of this sample representing 60%. We also found a moderate increasing loneliness class that represented 32% of individuals. And this was moderate loneliness at baseline, but they exhibited a significant increase in loneliness over time. And we found that having lower purpose in life was predictive of being in this class. We found that more agreeableness was predictive of being in this class, and poorer cognitive functioning was also predictive of being in this class. And we also found a smaller population of individuals, which was a high increasing loneliness class, where they started with high initial loneliness and that loneliness continued to rise over time. Greater psychological distress, childhood adversity, and lower purpose in life were all associated with being in this class. In this study, we wanted to see whether or not we could replicate those 4, whoops, sorry about this, I'm trying to move this floating stuff here. In this study, we wanted to see whether we could replicate those 4 quadrants in that I showed at the beginning of the talk. And so here we were looking to see whether we could profile these loneliness and social isolation asymmetry profiles. We used 1,200 adults from this midlife in the United States study. They were from the biomarker sample, which also had survey data. We used latent profile analysis. And as part of this latent profile analysis, we used loneliness and social isolation as the indicators in the profile model. In our outcomes, we wanted to see whether, first, could we find these profiles that represent this social asymmetry, and are they predictive of inflammation as measured by IL-6, CRP, and fibrinogen? And again, we were looking for this quadrant logic. Do we see this majority class with this low loneliness, low social isolation? Do we see a resilience class, which is given by low loneliness and high isolation? And we have vulnerable here defined as high loneliness, low isolation, and doubly vulnerable, we're calling it, which is high loneliness and high isolation. What we found after doing that analysis, the latent profile analysis, we did recover those 4 classes from that quadrant analysis. We found that the majority class represented the majority of this population. It was about 70% of this sample. And then we see the breakdown of the numbers for these other groups. The resilience group, that's high isolation but not lonely. Maybe we think about this as contented solitude or enjoyment of solitude. That represented about 14% of individuals in the sample. The vulnerable class, this is feeling lonely despite having social contact. This is people with unmet belonging needs. They represented about 11%. And then we had the doubly vulnerable class, which was a smaller class of individuals, and that's only represented about 5%. And these were the individuals experiencing both high loneliness and high isolation. But we didn't find any differences amongst these groups in terms of these inflammation measures. There were no predictive differences there. The last study I want to cover is thinking about well-being practices and whether social context comes up in that, and whether that we can understand what are people doing in their daily lives to flourish or live well. In this first study, we were looking at generativity as a buffer for social asymmetry. So generativity is this notion, it's the concern for and commitment for future generations. It's a key virtue in psychology and Erikson's theory of adult development. It's basically, if you have high generativity, you have a high concern and commitment for future generations. So we wanted to know whether this would act as a buffer against social asymmetry. Here, we had 645 adults from 2 years of the midlife in the Japan study. We had a measure of generativity. It was a 6-item Loyola generativity scale. And here again, we operationalized social asymmetry using this residual approach. So we had both cross-sectional and 4-year prospective association data here. And what we found was that higher generativity led to lower social asymmetry, but we didn't find that generativity change across 4 years. It did not significantly predict social asymmetry, suggesting that the cross-sectional link may reflect a stable protective trait rather than a dynamic process. But the implication of this is that promoting generativity may be a promising intervention to reducing loneliness in older adults. And in this last study here, we were thinking about what makes life go well using text data. So this is from a study called the Network Topic Modeling of Wellbeing Practices among adults living with chronic pain. We had 683 adults who were living with chronic pain coming from this midlife in the United States study. They answered the survey question, what do you do to make your life go well? So this was open-ended text data. They just responded with things like, I practice spirituality and faith. I spend time with my family and friends. We use network topic modeling, and the outcomes we were wanting to see, do any of these practices that people talk about to make their life go well, are they predictive of pain interference or prescription pain medication use? Because again, all these individuals are individuals living with chronic pain. We found 12 latent topics identified in the participants' responses. And these included things like maintaining social connections, living in the moment, avoiding stress, cultivating a positive mindset. These were all labels that we gave for these different topics. And you can see actual text responses from individuals who had high scores on these topics. So someone who said in their own words, keeping a good, close family and friends, family comes first in everything, keep them close. We labeled this topic as maintaining social connections. These were individuals that said to make their lives go well, they maintain social connections. There were also individuals that said, take things one day at a time and try to make someone smile. Take time to enjoy nature. And so we labeled responses like this, living in the moment. We also saw things like, I don't let stress rule my life. I work hard, but I don't take it home. And so this was what we called avoiding stress. And then we have cultivating a positive mindset there as well. These were the 12 topics overall that we found in this network topic model. And what we found was that maintaining social connections, it led to lower pain interference lower pain interference amongst these individuals living with chronic pain, as well as lower pain medication use. And so all of this is just speaking to an integrative framework for social foundations and flourishing. We just submitted an article where we're talking about how important it is to think about social asymmetry when thinking about the implications of loneliness or isolation. Basically, social asymmetry tells us that felt experiences of loneliness are much more important than structural disconnection. We see that using person-centered heterogeneity methods like growth mixture modeling and latent profile analysis, these can be really valuable for understanding heterogeneity and individuals' experiences of loneliness and isolation. You see it's important to look at context, culture, and lifespan implications. We see that culture moderated some of these experiences that individuals were having. And also it's important to think about flourishing and well-being and what are the implications of our social foundations of health for our flourishing and well-being in life. Some of what we're thinking about now is trying to develop a dynamic person-centered framework for social disconnection, which is looking at trajectories of social isolation and loneliness, this asymmetry across the lifespan. So here we're thinking about using something like a hidden Markov model, where we'd be able to see individuals transitioning between these different quadrants over time. So you can see in this hypothetical example, you might have this resilient class, which they're vulnerable stable at time 1, they're vulnerable stable at time 2, but then by time 3, they're in that majority class where they no longer feel isolated nor lonely. We need to also think about these dynamics over time, because just like heterogeneity at any one time can be important for understanding what might be important for implications for health, how people transition over time also might be important for their health as well. And we see some other hypothetical classes here. We could have like the green class, which we call stable flourishing. This would be a group of individuals that start in the majority class. Then at time 2, maybe they're feeling isolated but not lonely. Then they transition back to the majority class. And these are just some implications for intervention and future direction in this work. In measurement, we really want to compute asymmetry residuals to identify at-risk individuals. And we can use person-centered classification methods, which we see outperforming mean level approaches. And intervention targets might be to address subjective felt disconnection, not just the objective size of their network. We want to promote generativity, purpose in life, marital partnership, quality as modifiable protective factors. And then we can tailor interventions to trajectory classes. We can see if there are these different groups, what works for these different groups. Some of the future directions that we're thinking about: extending social asymmetry to model understudied populations, including racial and ethnic minorities, LGBTQ communities, examining social asymmetry in digital and online social context. Seems really important post-COVID when we were all under lockdown, and one of the primary ways that we communicated with each other was online. So what does it mean to be experiencing social asymmetry in a digital landscape? As well as test generativity-based interventions in randomized trials. And also, I'll note here as well, we're also looking more at this enjoyment of solitude. What is predictive of being in that class of people? These people who are isolated, but they don't feel lonely. And these are just the conclusions of these different studies. But that's everything I have today for these different studies I've been doing in my work. Thank you for your attention. Do you have a question? Okay. Yeah, I'm happy to take questions. I also have this text data from this study here. It's synthetic data based on the actual data. So this data, it comes from the Midlife in the United States study. They have a policy against using this data in large language models. So unfortunately, you can't actually use that data in large language models. But what I did was I also work with this data with a group that qualitatively coded the data. So I have qualitative codes from every individual. And what I did is I fed those qualitative codes into an LLM, and I computed a bunch of features about the data, like how many words did an individual use, how many topics did that individual endorse based on their qualitative coding, and simulated synthetic data to represent this data that I thought we could work with today.
I think more questions will come up once they start
Yeah. Yeah, a lot of this, different studies, different methods. I can answer any questions about mixture models if you wanted to explore that as well. But for this, I felt like, they were mentioning that the focus of this summer institute is on large language models, so I thought this text data would be really appropriate.
Yeah, actually, that is what I was planning to ask. I would like to hear a little bit more about your methodology, because in one of your studies you're using growth mixture modeling, and in another one you're using latent profile analysis. Both are based on categorical latent dependent, not dependent, but variables, let's say. So, what is the basic distinction between the use of these two different methods? Because I'd like to hear a little bit more about why you prefer those methods and try to, detail this.
Yeah, so I'll just use this as an example. Growth mixture modeling and latent profile analysis both use continuous observations as the outcome variables for the analysis. There are methods which are extensions of these that handle categorical outcomes. So one is called latent class analysis. This is the counterpart to latent profile analysis here with cross-sectional data when you have categorical data. So latent profile analysis is a mixture model for when you have continuous data. That's what we're seeing here. We had continuous measures of loneliness. We had continuous measures of social isolation. If you have at a cross-sectional data categorical, you use latent class analysis. Growth mixture modeling, if you have continuous data over time, you're going to use growth mixture modeling. If you have categorical data over time, you would use something like a hidden Markov model. It would look more like this. So in our study that we did, we had loneliness scores at time 1, time 2, and time 3. It was continuous data, and we fit the growth mixture model to that. If you have categorical data over time like this, or maybe I've labeled people into these 4 different groups, then I would use something called a hidden Markov model, which is a type of mixture model with categorical data over time. Why you would use these mixture models is because there's a distinction between what we call variable-centered methods and person-centered methods. Variable-centered methods are when you look at the average effect of some variable on another variable. So any regression model that you use is a variable-centered method. It's because you're really thinking about what's the average effect of maybe social isolation on loneliness. Whereas in a person-centered approach, what's different is no longer are you concerned about the average of some variable, like in this case, where was it? Sorry. You're not looking at the average of loneliness and its effect on some outcome. You're not looking at the average of social isolation and its effect on outcome. What you're doing is you're creating classes of individuals. You can call this a categorical variable. It is a categorical latent variable at the most technical level. And in this context, you've now labeled people as belonging to one of these 4 classes, and you're seeing what's the effect of being in one of those 4 classes on some outcome, as opposed to just looking on average, what's the effect of loneliness? On average, what's the effect of social isolation? I've now placed people into these classes and said, what is the effect of being in one of these classes on some outcome? So they call it person-centered because you are putting people into these different classes. Any other questions before I get into the code and the data?
As a follow-up to that, so what I'm saying is person-centered modeling in any way akin to random effects?
It is similar in a way, yes. And so the idea with a random effect, if you're thinking about multi-level modeling, for example, is that the context that you're thinking of the random effect in? So in that context, you are able to estimate an individual, let's say, intercept or slope for every cluster in your sample. And that is a latent variable. It is a sort of person-specific estimate. So in that way, it is similar. But, those approaches are kind of different. They answer different questions. It's not quite the same in that you kind of put people in the profiles either, right? So you're actually, when you use a multi-level model, you kind of use that random effect to deal with nuisance correlations amongst individuals. in your regression model. So, when you ignore that clustering of individuals in a multi-level model, your regression model standard errors are biased. They're no longer appropriate. They're smaller than they should be, and you'd be more likely to make a type 1 error, where you basically say that something is statistically significant when it's actually not, because your standard errors are suppressed, sorry. So you use that random effect and use multi-level modeling to correct your standard errors, but you're still taking a variable-centered approach, because you still are often interested in what's the effect of loneliness on some outcome, accounting for that clustering. You're usually just clustering to get some kind of, deal with that clustering. It's kind of considered a nuisance. You don't place anybody into a category.
So these categories are all theory derived. They're not data derived. They're not based on classified data.
This is not theory. We label them, so we label them. That's a theory, but it's all data driven. So it's exploring the data, saying you have to find how many classes there are. So you'll fit a model with 2 classes, then you'll fit a model with 3 classes, then you'll fit a model with 4, 5, and so on, as many as your data could support. And there's different statistics to decide how many classes should I choose. One of them is called entropy, and it tells you kind of how well separated these classes are in your data. So it's looking at specifying the classes. It's giving them a mean. They have a variance. We don't see it here. This class has a mean on this variable. It has a variance as well. And saying how well separated are these classes. And it's trying to find in your data the best well-separated set of classes. And then once you've identified it, like in this example, it told us it was 4 based on the entropy. And then it's you can look at your data and it says, 70% of people are in the majority class, 12% are in the vulnerable class, 13% are in the resilience class. Whereas in a random effects model, again, you're just sort of dealing with kind of people having differences on a variable rather than modeling those directly.
Mike started to get done. I'm sure more questions be
Yeah, so there was a folder that was shared with you.
shared from the WhatsApp.
So these are all the data that are in here in this folder. Oh, I have to delete this one. What you have in here is some de-identified data. There's some synthetic qualitative data in here. So I'll show you this. These are de-identified data. I've kind of simulated these IDs, so they're not the actual IDs from the data. These are the actual qualitative codes that came from another study that I was involved in, where they did a qualitative analysis of this. They did a traditional qualitative analysis. They had undergraduate RAs, they labeled the data, they came up with these codes. The definitions of all these different codes are in one of the data files or one of the script files that I've shared with you. Sorry, one second, I'll pull that up. So if you open the topic modeling EGANet, it gives you definitions of each of these labels. So CG underscore A, that's positive relationships. CG underscore C, that's faith, integrity. So you can read which of these, what are these qualitative codes? And so here, a 0 means that this individual here, so this is ID, make this a little bit bigger. So here, ID P0733, they didn't endorse that first qualitative code. They endorsed qualitative code C, D, E, They didn't endorse F, G. So this was the traditional qualitative coding. And these are real codes from that actual data. This tells how many characters were in their actual data, how many words were in their actual data, how many sentences there were. It's giving you some other information. So I use this all these different features to generate this text data. And I put that data file that I used to generate that text data in that folder as well. So you can take a look at that if you're curious. And this is what it ultimately generated. It generated some response to that question, what do you do to make your life go well? And they said, taking time to reflect on my own thoughts and reactions has helped me handle things more calmly. Along with even when no one is watching, I try to make choices that I can be proud of later. So it's some response that was generated based on all these features here. There are two script files that I've put in here. One is based on this topic modeling method that I discussed in my series of studies. It's called network topic modeling. It's using a package in R called exploratory graph analysis. So I've worked through an example of this using that data. But one of the things that comes up here, and I'll show you as I go through it, is you have to decide on how many topics there are. And I've built a pipeline for kind of choosing that, and I'll show that in a second. But one of the things that I think you could work on in groups is try to figure out maybe what is the optimal topic structure. And you can do that by looking at the kind of pipeline for choosing that, which I'll show in a second, but also thinking about what I've done here as well is in addition to these qualitative codes I provided you, bless you, I provided you with their cardiovascular health as an outcome variable. So you could predict from the different topics that you find whether any of them have implications for cardiovascular health or not. And you might look at like the R squared or some other statistics to figure out which set of topics is most predictive of that outcome. So that's a kind of challenge that I've embedded at the bottom of this document. The other thing I have here is using zero-shot theme analysis. So using a Huggins-based transformer model, LLMs, where it's using Roberta in this example. You can work on this approach and try to compare using an LLM theme analysis to a topic modeling analysis on this data and try to come up with the model that you think is best at predicting this cardiovascular outcome from this qualitative data. So let me walk you through this data a little bit to kind of get you familiar with it and kind of how these topic models work. Has anyone used topic modeling before? Has anyone used network analysis before? So this is kind of this is a blend of kind of both network analysis and topic modeling. So topic modeling in the computer science literature traditionally has used what's called latent Dirichlet allocation to fit a topic model. It's a type of mixture model, another latent class analysis or latent profile analysis that I was talking about before. This approach, rather, what it does is it looks at the correlations amongst word usage across documents, and it tries to say, then it puts those correlations in a network, and it tries to find whether or not there's any densely connected set of communities of words. So that's the difference between network topic modeling and latent Dirichlet allocation. So this code book here is just telling you what the labels are in the original data. We know that there are 12 topics that came out of that qualitative analysis, traditional qualitative analysis. They labeled these responses, including positive relationships, faith, integrity, self-awareness, positive attitude, enjoyment, coping, health maintenance, learning, work, personal finances, and planning and organization. So these are topics that individuals say they do to make their life go well. The data here, you just need to change the path. Sure, many of you are familiar how to do that. So just change the path to this synthetic qualitative data final.xlsx file here. It's just pointing to the file on my computer. You need to point it to the file on your computer, however you want to do that. I'm using the Rio package to import that. Of course, I changed the path name, so it's going to tell me there's an error. And so here in this first step, I'm just filtering out any data with actual node data here. There were missing data in the real data set. So when I imputed the synthetic data, it came through as missing data. This is just telling you what was the dominant code for each individual's response. So in general, we can see that the majority of respondents had code CGB as their dominant response. But you can also see here that many individuals endorsed many themes at once. So CGD is integrity here. A lot of people mentioned integrity. So here you want to load up the EGANet package. So this is called the exploratory graph analysis package. We also have the topic modeling package and our text binding. I can't remember which one that is. The snowball package. These are just some basic text functions that we're going to use to clean the data. So you can remove URLs, punctuations. Here I'm removing all of this. I'm removing stop words. These are things like the, and, or, things that we don't really consider like important language in these types of analysis. We convert it to a document term matrix. This is one of the things that I think is really challenging in this type of analysis, which is we have this document term matrix, which is telling us we have 2,077 documents. These are individual responses to this question, what do you do to make your life go well? And saying after doing this text cleaning, there's 450 unique terms. But there's also this sparsity measure here, which is telling us, in an individual's document term matrix, how well populated is it, or how sparse is it? How not populated is it? Because in the document term matrix, you have for every document, you have all the terms that could be possibly indicated in their data sets based on everyone's responses, but not everyone uses every single term in the data. Rather, they'll only use a combination of whatever was in their response. So some people have more sparse responses, some people have less sparse responses. But what's the optimal level of sparsity? In the past, when I've taken some workshops on this, they just say it's an empirical question. What this is trying to do here, and what I've done in my own research using this method, is try to come up with some way to search for the optimal level of sparsity. And you can tinker with this a little bit if you want. This could be a place where, you could maybe improve this decision-making process about what is an optimal level of sparsity by updating this pipeline of code here. Yeah.
I was just wondering the same thing. So in the code, you are doing this from 85% to 97.5%. You're trying different sparsity measures, increasing by 0.5%. So based on that, you have an entropy fit. And I suppose that you're deciding based on that, right?
Yep.
And so there's an optimization problem here.
That's how I've framed it. So I'll show that really quickly. There's a bunch of details, maybe other ways that you could do that, but she just summarized it perfectly. I create this sparsity grid. I'm going to try different sparsity levels out. I'm going to collect along the way the number of terms at that sparsity level, the number of documents that would be kept at that sparsity level, the optimal steps. This is coming from the EGANet package. So what is happening is it's based on your set of words. It's creating this network from those word correlations. And then it's running what's called a walk trap algorithm. How many of you have heard of that before? So it's based on a network, and it walks around the network, and it tries to find these densely connected set of communities. And it says based on this, there's 5 communities. We take this to be the number of topics in the data. And so here, that's what it's telling you. It's trying to pull out the optimal number of steps in that walk trap algorithm. And then it's going to give you that entropy fit at that level of sparsity. And it's also telling you whether or not this model converged. So what I've seen is that when you get to some levels of sparsity and there's not enough information, the model fails to converge. So we want to track that as well. So when you run this, it's trying different sparsity levels out here. It's telling you whether it's converged. It's telling you how many documents are kept. Takes a couple more seconds here. There's still some ambiguity though about, we are trying to optimize this, but you'll see like what's the optimal level? Is there a clear decision point? Because what you see is that this entropy, it has the characteristic that as the sparsity goes up in this number, the entropy tends to go up as well, but you'll see it has a particular pattern. Just show you this plot real quick. Okay. So this is the sparsity along the x-axis here. So I'm increasing that sparsity number and I'm collecting at every sparsity level. I refit this model. I fit the exploratory graph analysis and I collect what's called the total entropy fit index from that network, which is a characteristic of the number of communities at that sparsity level in the network.
It's kind of localness.
Well, that's where I think is the challenge here. Is like, is that point that I've identified here the optimal point? So in psychometrics, there is a method called factor analysis, exploratory factor analysis. You try to find the number of latent dimensions underlying a data set. One way they do this is a very similar graph as this. It's called a scree plot. It looks at, factor analysis. You have a set of items. You believe that there's some dimensions underlying these items. It might be that you have a set of items to measure math ability. You have a set of items to measure reading ability. And you believe that there's a math ability dimension and there's a reading ability dimension. So you have your data set. It's a bunch of ones and zeros of people answering these items, the math and reading items. You can calculate a covariance matrix from that set of items. And then what they do is they get the eigenvalues from that covariance matrix, and they determine the number of dimensions underlying that covariance matrix. And they do that through a scree plot of the eigenvalues, they call it. And what they do is they try to find an elbow in that scree plot. And so using that same logic here, I think you want to try to find you can call it a local maximum, an elbow here. That's why I've identified this point. But all those points right just beyond that, there's 5 more that do lead to converging solutions. One thing that we do see is that once the sparsity gets way out here, no longer are these solutions converging. There's not enough information. So you have to choose amongst some set of these the appropriate sparsity level. And here, this is a sparsity level of 0.9. It results in 73 terms. But it's definitely debatable. I mean, who's to say 0.91 isn't slightly better or 0.93? And this is where I would, if I was doing this, explore each solution right around this range, right at this kind of elbow, because it looks like these are all similar to each other. I wouldn't say there's much going on different. I'm trying to find somewhere here where it starts to go down, but it's not, not converging. So it's kind of local optimal space, but you also want to find a solution that you can actually interpret. So one challenge here is that some of these solutions may not be as interpretable as others. I'm just picking one here, which I think is the elbow. That's what I might go on. But it might be worth to look at, the solution just to the left of that elbow, the solution just to the right of that elbow, and decide this one has the best interpretability here. So that's the one that I choose. Otherwise, you have a solution which you can't actually interpret. Because one thing, as you'll see here when we run this, you have to interpret the output. So once you run a little bit further, you'll get this network, and it's showing you the different words in these different communities or topics, as we call it, showing you how important they are in this network. It's labeling the size of that node as how important that word is to that different topic. But now you have to label this. There is a qualitative element to topic modeling, which is, how do I know what this is talking about? I didn't put it in here, but you can easily get it. You can, because what we do in this next step is we get these topic scores. You could look at individuals that have the highest scores on one of these topics and read their responses to figure out what are they talking about? What is this topic about? And that's typically how we label them.
Can you plot this kind of like as a 3D plot where you have the clusters and then the points are the inputs, so that if you go with your mouse to the cluster, like it comes up and you just have exactly, would that be possible, or is this kind of the plots that are normally used?
It's the one I use, but I'm sure, there's other plots that you can use. So here you're thinking about what along each dimension.
Yeah.
What are your 3 axes?
Yeah, I'm not really sure if you really need values or whether you can indeed just cluster them together and just plot them out in a random map. And then they will probably have shape.
My guess is there's likely a shape. I haven't considered it before. So covariance matrices do have shapes and people have explored that. But I don't have that kind of worked up here, but that might be something to look into.
Shape, because then you probably also have semantic information in the shape.
Yeah, and there is some shape here already in kind of how they're clustered and what's central in this network. So you have to label these topics. One way you can do that is you compute these net score topics, which are basically the individual scores on these networks. So what they do is for each individual's response, if they're using a lot of these words in this topic, they get a high score on this topic. So that's what the net scores topic is doing. It's giving individuals scores on each of these topics. So you could then say, I want to interpret topic 1. I don't know what topic 1 is. Let me look at the responses of individuals who have the highest scores on topic 1 to qualitatively make sense of what this topic might mean. That's what these standardized scores are here. So here you compute these score topics. What I've also done is in this plot, you can look to see how does the topic, let me make this a little bit bigger. So remember, we have the original qualitative codes in this data as well. So what this is doing is it's plotting these scores by the different topics. So maybe we might be able to interpret the topics based on which of these qualitative codes has the highest scores. Topic 2, for example, looks like it's likely CDC, or sorry, CDD. You want to blow that up a little bit and make it bigger, but there's the highest scores for CDC for those who had that qualitative code. So that's another way to look at it as well. But what I did in that study where I said, okay, I fit this topic model. Now I want to know, does it predict chronic pain use? Does it, or pain medication use and pain interference? I use those network topic scores to predict some outcomes. So here we also have this cardiovascular health data. So if you merge in this data, it's coming from the data set, which is called CVH data de-identified. You can merge this in and you can predict. In this example, I'm just using a simple regression. Here now we have for each individual, we have their topic score on all the different topics. We have their actual qualitative label in that well-being column, but we also have their cardiovascular score at wave 3 of this data, which is 8 years after the text data were collected. You also have their cardiovascular score at the same wave that the text data was collected. You have a different score for them as well. So you could predict these to see which of these topics might be most predictive of cardiovascular health. That's what this example model is doing here and showing you that topic 1 is predictive of worse cardiovascular health in this example. So that could be the challenge here, to work through this code, see if you can come up with a topic solution, which is really predictive of cardiovascular health. And there's some also information about pulling like the R squared, the adjusted R squared, AIC, BIC, as well as doing some cross-validation for this analysis as well. So that's what's in the first file. The second file is using zero-shot theme analysis. You need to have Python set up on your machine, work through this. But here I have this environment set up. I'm using Reticulate, which is a R package that allows you to run Python within R. Many of you use Reticulate. So this is just loading. I changed the path name again. So this uses this function text zero shot to come up with labels using a zero shot classification model. And it's using the qualitative labels as the candidate labels to learn this. And then it's the same idea here, do a little bit of validity analysis to see whether or not it does a good job at actually recovering those candidate labels or not. So another task that you could do is just, where I haven't had much time to work on this myself, but I thought it would be a good exercise to try to use these qualitative labels as ground truth data for what these text data were actually coded as, and see whether you can use a different LLM model. I just use the NLI Roberta base model. I'm not too familiar with too many LLM models. Maybe you've all learned about some LLM models that might be better here. You can try out different models. And in this code here, it works through cleaning up the themes once you get them. Then it's comparing these zero-shot classifications to the actual qualitative data. That's what this validity analysis does. It calculates your true positive rate, your false negative rate, you get your accuracy, precision. And then it does some analysis on the theme. So I tried to use the EGA net on these actual themes that come out of this LLM model. Again, completely kind of untested stuff, but I was just tinkering around with it. So you can look at some of the networks that emerge from these LLM themes as well. And then this last part, it's looking to see whether people who are high in CVH versus low in CVH, do they have similar networks or not on this qualitative codes that come out of the zero-shot classification. And then also the challenge here is to predict CVH change from these zero-shot theme scores. So just like in the topic model where we tried to predict CVH with the topic scores, can we predict them with these theme scores that come out of the LLM? So I'm not sure how you guys kind of usually run the workshop. Do they work on their own?
Yeah.
Should I come around and kind of talk about the code if people have kind of issues with it?
Basically, like, set either like one challenge, if you have a challenge after this, and they can work on it, or they can just ask them to do exploratory analysis, how that's a new to me, and then just move around. So I can move around, just like ask them.
Yeah, I think one thing to do is try to get both of these to run and see if you can do the head-to-head comparison. So here in this part of the code, I'm saying a head-to-head, we're going to compare the topic model versus the zero-shot model and see which has better statistics in terms of predicting CVH. Then I think if you can make it that far, it would be about, can you tweak the model and improve it, maybe make a decision somewhere along the line in this code, which is pretty well documented, to maybe get a better prediction, a better higher R squared. So within each of the models, you could do that as well.
Anything unclear? You have any questions? You're 100% sure what you're going to do. Well, thank you so much.
Okay. When this runs, I'll show people as well. It's kind of